So we're going to work through this Module 7 corrective review. So the first problem is a decagon is shown. What is the sum of the interior angles of the decagon? So a decagon has 10 sides. The formula for the sum of the interior angles is the n minus 2 times 180, where n represents the number of sides. So to find that for this one, we'll take the number of sides 10 minus 2 times 180. So that means take 8 times 180, plug it into your calculator. You should get 1440 degrees. If the above decagon is regular, what is the measure of each of its interior angles? So the key word here is regular. A polygon is regular if it has all congruent sides and all congruent angles. So if this is a regular decagon, it should have 10 congruent angles inside. So if we know the sum of all the angles is 1440, we know that there are 10 congruent angles. Divide the sum by the number of sides and angles, and each angle then should be 144 degrees. A polygon has an interior angle sum of 3240. How many sides must the polygon have? So we're going to use the same formula from up here, the n minus 2 times 180. This time we know what it should equal. So n minus 2 times 180 should find the sum, which we happen to know is 3240. So that means we'll divide both sides by 180. That'll leave us with n minus 2 is equal to, it'll be 18. So we have to add 2 to both sides to get this polygon has 20 sides. The measure of one interior angle of a regular polygon is 135 degrees. What is the total sum of the interior angle measures? So this is similar to what we did in part 1b. We found the sum of the angle measures divided by the number of sides and angles. And that should be equal to what one interior angle of a regular polygon is. So we know that our n minus 2 times 180 divided by the number of sides should be equal to one angle. So in this case, we'll multiply both sides by n. Those will divide out. We'll be left with the n minus 2 times 180 is equal to 135 times n. So now we'll want to distribute in the 180. So we'll get 180n minus 360 is equal to 135n. If we subtract the 180n from both sides, we'll get negative 360 is equal to negative 45n. Divide both sides by 45, we'll get that n is equal to 8. Now, the problem, though, asked what is the total sum of the interior angle measures. So now we'll have to plug that back into the n minus 2 times 180. Sorry, we'll make that 8 minus 2 times 180, since that's what our n is, for a angle sum of 1080 degrees. Moving along over here, Polygon Abcd is shown below. What is the best name for its shape? Well, it has 4 sides, so that makes it a quadrilateral. Pentagon has 5 sides. A polygon just means it has many sides. So if we want to find the measure of angle B, first of all, we'll have to find the sum of the interior angles. So since this is a quadrilateral, we know we could divide this into 2 triangles. So 180 times 2 triangles means the sum of the angles should be 360 degrees. So if we add the 4 angles, 4x plus x plus 4x plus x should be equal to 360. So that means 6x is equal to 360. I can't add, sorry. I was wondering why that was coming out wrong. 10. 4 plus 1 plus 4 plus 1 is 10. Sorry. 10x is equal to 360. Divide both sides by 10. X equals 36. However, we want to find the measure of angle B. B is 4x. So 4 times 36 is 144 degrees. Can a triangle be made with side lengths of 5, 5, and 9? So the way we check, we take the 2 smaller sides added together. They should be bigger than the third side. Are they? Yes. So how do we know? I suppose technically we could call it use the triangle inequality theorem. That's the one that says two sides have to be bigger than the third. Again, we kind of cheat a little bit. I guess not cheat. We're smart about it, and we always just check the two smaller sides to make sure they're bigger than the third. What are the possible side lengths for the triangle below? So we've got two options. X could be one of the smaller sides, or X could be the biggest side. If we want X to be one of the smaller sides, when we do our triangle inequality, we check the two smaller sides. Added together should be bigger than the third. So doing that, X has to be bigger than 4. Let's say, though, that X is the biggest side. So that means the two smaller sides would be 8 and 12. In that case, that would be bigger than X. 20. So that means X has to be less than 20. So the possible values for X has to be greater than 4, but less than 20. So for the triangle above, what's the largest possible perimeter? Well, X has to be less than 20, so the biggest value X could have technically would be like 19.999 repeating. So if we add up the two sides we already have, plus 19.9 repeating, the largest possible perimeter would be something like 13.99 repeating. What's our units on this? Centimeters, technically, since X has to be less than 20. Okay, in triangle MLT, which angles are exterior angles? So exterior angles are angles that are outside of the triangle. So the ones outside of the triangle here are angle 4 and angle 5. In the triangle above, which angles are remote interior to angle 4? Well, remote interior angles are the ones that do not touch that exterior angle. So in this triangle, angle 1 is touching angle 4. So that means angle 2 and angle 3 are the remote interior because they do not touch that exterior angle 4. What's the measure of angle 2? Well, there's a couple different ways we could do this. If we want to solve this using the exterior angle theorem, what we'll need to do here is notice that angle 3 and angle 5 are a supplementary. So because they are a linear pair, so we take 180 minus 115, that tells us that angle 3 is 65 degrees. So from there, we could use our exterior angle theorem to say the exterior angle, which is 105, is equal to the sum of the two remote interior. So that means angle 4 should be equal to angle 2 plus angle 3. So we'll call angle 2x plus angle 3 we said was 65 degrees. So subtracting 65, we'll find that the measure of angle 2, 105 minus 65, gets us 40 degrees. Okay, in this one we want to find the measure of angle PQR. So again, we want to use the exterior angle theorem. So that means our exterior angle 11x plus 24 is equal to the two inside angles it's not touching added together. So 62 plus 7x minus 6. So we subtract the 7x to get 4x over here. We take 62 minus 6, which is 56. 56 minus 24 will get us to 32, which means that x is 8. Solving it back in for angle PQR, take 11 times 8 plus 24. So the measure of angle PQR is going to be 112 degrees. And what theorem helped us answer that? Again, that was the exterior angle theorem. All right, so the isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite of those sides are also congruent. What does the converse say? When we take the converse of a theorem, we switch the hypothesis and the conclusion. So we change the order of our statement. So we change everything after the word if and then is what we switch. So if, now we'll look at the second part of the statement, the angles opposite those sides are congruent, then the two sides are congruent.